Hi and welcome, you amazing people. In this video, we'll start integrating the concept of a view model into our project. So far, we have been using mock data from our preview helper right here, which works fine for building the UI, but it's not scalable when you need the app to actually perform real tasks. So if we come back to our home view and start looking after the place where we populate this journal entry list, that should be under main content, go with the command and click to this cells view. And here we have a for each, and we see that for now we iterate over the mock data helper journal entries. And the first thing that I want us to achieve is moving this mock data source to our view model. So let's just do that. So under the home feature folder, right here, we have a subfolder called view models. Let's try to use this folder. So new file from template, Swift file, let's call this home view model. Create. Now let's define our class. Let's make it final class on view model to conform to observable object. And let's just create a simple init. There we go. And some short notes right here. The observable object is a protocol in SwiftUI. It basically allows a view model to notify SwiftUI views when its data changes. For example, if we would have here the journal entries data source and we would do some logic on that data source, like modify it, filter it, or maybe an external service will modify it. This view model will publish those updates to our views, and our views will update their content in real time. So that way we make sure that our views are refreshed and are up to date. More importantly, when we have complex logic that updates the view, it's crucial to use a view model. By moving the business logic out of the view and into the view model, we keep the view clean and focused solely on presentation, while letting the view model handle data processing and updates. So this is the approach that we will be taking for our app. Let's start moving our data source to our view model. So let's define a journal entries array. We need to use published private set var journal entries of type journal entry, and the default value is going to be empty. We use private set because we want the seller to be private, but the getter to be public. So when a view tries to read the journal entries from the view model, it will be able to read it, but it will not be able to modify it. And that's really important. Now let's go back to our home view and define our view model. We're going to use state object, private var view model, assign directly a home view model. Now let's say on appear right here, just for an example, we can access the journal entries from the view model. There you have it. So we can modify these journal entries inside our view model, and we can access it in our view through this private variable called view model. So now you might wonder why we use a state object wrapper here. So this wrapper is used to create and manage a view model's lifecycle inside our SwiftUI view. It ensures that the view model is only created once and retains its state. And that's really important to remember. It retains its state, even when the view is re-rendered. As you might know, a SwiftUI view is redrawing once it finds something that triggers a change inside it. But we want our data source to remain constant. We don't want to change that when the view is re-rendered. Okay, now we should be able to change our list from our mock data helper to our view model data. So let's try to do that. If we go to the cells again, and instead of this code, let's just type view model.journal entries. And surprise, surprise, we have no data. Why is that? Because if we go back to our view model, we can see that our data is empty. So for now, in our init, let's say journal entries equals preview mock data helper dot view journal entries. Let's go back to our home view, and everything should work just fine. So wait a minute, we're still using the preview mock data helper? Yes, we will still using it, but we've made an important step by moving the logic into our view model. This gives us the flexibility to swap between mock data, backend data, or even local storage easily, all without cluttering the view. Good job to you for doing this. So in order to show you the power of this change that we just made, we should simulate a backend fetch. So initially our journal entries are empty, but we will add the hardcoded delay right here somewhere. And after that delay finishes, we're gonna populate our journal entries with our preview data helper entries. And by doing that, we can build a loading indicator that will let the user know a time-consuming operation is happening. So in our home view, let's create that spinner. First, we need a boolean to trigger the visibility of the spinner. So just type state private var show toolbar loading spinner of type bool, and the default value is false. Now in our toolbar, besides having an add button, we should add a spinner. But the spinner is added only when the boolean that we just created is true. Now let's go to our extension where our subcomponents are placed and type the following: private var toolbar progress view some view. We need a progress view that is native in SwiftUI. The style of it, so progress view style, is gonna be .circular, and the tint is gonna be our accent color. App color theme .accent color. Great. Now copy this and let's place it here. For now, obviously nothing happens. No spinner is shown here because we need a way to trigger this boolean. And because we have a view model, let's just cut this entire line and move it inside our home view model. Instead of using state, we're gonna use a published, and we're gonna make it private set var. We can read it, but we cannot modify it externally. Now, if we go back to our home view, we're gonna have an error right here. We should just use our view model dot show toolbar loading spinner. Everything should just be fine. This is the beauty of a view model. All the logic that should be done to show or hide this loading spinner is done right here in our view model. And the view is really dumb. It doesn't know why the spinner is shown or why the spinner is hidden. It only knows what the view model tells the view. And now let's simulate that backend fetch. Let's create another function here, private function fetch data. And copy this and just paste this function in the init. And now in order to introduce that delay, we're gonna use a dispatch queue dot main dot async after. For the deadline is gonna be now. And we're gonna add, let's say 3 seconds. And after 3 seconds, we're gonna populate this journal entries array with a preview mock data helper array. And that way, this assignment will happen after 3 seconds, giving us a feel of backend fetch. It complains that here it needs a self because we're in a closure. Everything should work just fine. Let's go back to our home view. You can see that the fetch happened with a delay, but we haven't seen any spinner indicating us that a backend fetch is happening. So let's see what is the problem. Of course, we need to trigger this spinner. So before having this block of code, we should trigger the spinner boolean. So show toolbar loading spinner is gonna be true. And after we fetch the data, we should hide the toolbar loading spinner. We need a self here. Let's go back to our home view. And we see the spinner. The data is fetched and the spinner is hidden. It's really cool. And that's a wrap for this video. We are closer to a finished architecture, but not there quite yet. But today we focused on migrating our data source from the view to the view model and discussed why using a view model is crucial for a better architecture. We also walked through simulating a data fetch along with adding a spinner to keep the user informed while data is loading in the background. In the next video, we'll dive into the repository pattern, adding another layer between the view model and the repository to handle data operations like fetching, saving, updating, and deleting. Until then, happy scribbling!